Hello and welcome back to part 2 of 5.4. We're going to look at the quotient rule for radicals. So we look at this rule that if the square root of a and square root of b are real numbers, then the rule that we've been using before, that we can split the radicals apart into two separate pieces of the fraction and work with them then. So let's go ahead and start with problem set 3 and let's take a look. So let's just use the rule that we used in the beginning of breaking down the fractions. We're just writing the square roots on top and bottom. The square root of 125 over 16, break that into the fraction square root of 125 over the square root of 16. Let's break that down. We know that the square root of 125 is the product of 25 times 5, and then the square root of 16 on the bottom can be written as 4 times 4 into the radical. So that 25 is a perfect square. It can come out of the radical, leaving that radical 5 underneath it. And 4 times 4 is a perfect square, so we can pull a 4 out. Looking at number 2, let's break the square root of 100 over 45 into the square root of 100 divided by the square root of 49. Both 100 and 49 are perfect squares. The square root of 100 is 10 over the square root of 45 is 7. Looking at number 3, we have a negative out in front, so that will not disturb us with having to work with imaginary numbers. So let's break this down into leaving our negative out in front and then breaking our fraction into radical 175 over the radical of 100. 175 is not a perfect square, so we're going to have to break it down into perfect squares. 25 times 7 yields 175. And on the bottom we know that the square root of 100 is 10. So if we look, we have our negative still. That 25 can come out of the radical as 5, leaving 7 under the radical. We have our 10 on the bottom. And now we can use some simple algebra to make our fraction become making 5 go into itself once and going into 10 twice. So that's going to leave us with a negative square root of 7 over 2. Looking at number 4, let's break down the square root of 30 over 90 into the square root of 30 divided by the square root of 91. Or excuse me, that is 81. It's 81, not 91. The square root of 30 can be broken into, well, it looks as if the square root of 30 cannot be broken into any square roots because it's only multiples of 30 are 1 and 30, 5 and 6, 3 and 10. So we can't do anything with that. So we can work with the 81 on the bottom. That is actually the square root of 81 is actually 9. So that will be our answer for this problem. Now if we look at problem set 4, add or subtract as indicated. This is a lot like working with fractions. What you want to do is combine like terms. That means terms that have radicals and the stuff inside the radicals are the same. So for number 1, 9 square root of 3 plus 2 square root of 3 minus 8 square root of 3 minus 5. We want to combine everything that has a radical 3 in it. I like to go through and underline or bracket everything that has that in it. So we have a 9 square root of 3 plus 2 square root of 3 minus 8 square root of 3. So we combine, let's write our square root of 3 and have our 9 plus 2 is 11 minus 8 is 3. And then just bring the negative 5 down. looking at number 2, these two share a common radical, while the square root of 5 does not. So we can combine the 7 square root of 2 and the minus 6 square root of 2. Let's have the square root of 2 down there and have the 7 minus 6 as just 1, and drop the square root of 5 down there. Continuing with these examples, we can see that 3 has 3 square root of 7 plus 5 square root of 7 minus 6. These two can come together with the square root of 7 having the common terms, so 3 plus 5 is 8 minus 6. Finally, let's look at number 4. Notice that there's that one coefficient in front of that. So we'll just bring that 8 down, and note that our part of the radical will have the radical 2 in there. So we have a minus 1, minus 5, or minus 6 radical 2. Now let's briefly talk about rationalizing the denominator. To rationalize the denominator, there must be no square roots in the denominator. To rationalize the denominator means to multiply both numerator and denominator by the square root that appears in the denominator. To rationalize denominators using conjugates means to multiply both numerator and denominator by the conjugate of the denominator. And we'll get to that part in number 3 and 4. So for number 1, here is the square root of 2. If we were to multiply by 1 in the form of square root of 2 over square root of 2, it will alleviate the fraction of having a radical in the bottom, hence the name rationalizing the denominator. So let's go ahead and multiply. We have on top square root of 11 times square root of 2 over square root of 2 times square root of 2. We can combine these into square root of 11 times 2 over square root of 2 times 2. This is going to become square root of 22 over square root of 4, which becomes square root of 22 over 2. And that's as far as you want to take it. Number 2, let's look at breaking this fraction down into its separate pieces of square root of 3 over square root of 11. Now let's multiply by the form of the denominator we're trying to get rid of, or 11, so we multiply it by the fraction square root of 11 over square root of 11. Combining these, we get the square root of 3 times 11 over square root of 11 times 11. So we're going to get square root of 33 over square root of 121. And that's just going to become square root of 33 over 11. Okay, looking at example 3, this is what we're going to do with conjugates. So what you have to do with conjugates are multiply still by 1, but instead of the same denominators we used before, instead of this plus, you want to go with the minus. You want to go with the opposite sign in the center. So when we do that, we're going to have 2 times 2 minus square root of 5 on top over the quantity 2 plus square root of 5 times 2 minus square root of 5. And we have these opposite signs, as you might remember from factoring. We're going to cancel out any middle terms that may have radicals in them. Excuse me. So if we were to take the 2 and distribute it to everything inside the parentheses on top, we'd have 2 times 2 plus 2 times a minus square root of 5. And if we work on bottom, let's take our FOIL terms and multiply it across everything inside the parentheses. So we're going to start off with 2 times 2 plus 2 times a negative square root of 5 plus square root of 5. So we're going to FOIL this term now. So we have square root of 5 times 2 plus square root of 5 times negative square root of 5. Let's go through and simplify. So 2 times 2 is 4 on top, plus, or excuse me, a minus, because we have 2 times negative square root of 5, so this is what we're left with on top. On bottom we have 4 plus, excuse me, we have a negative 2 square root of 4 plus 2 square root of 5, excuse me, I should have said 5 for this, and then minus square root of 25. So we just carry what's on top again. We're going to simplify what's on the denominator. So these are going to cancel out, and this is actually going to become a 5. So we have 4 minus 5, or just negative 1. And what that essentially does is change the sign of everything on top. And I believe for our last example, number 4, let's multiply by the conjugate. And the conjugate for this case will be square root of 10 plus 3 over square root of 10 plus 3. And remember, this is just a form of 1 we're multiplying by. Okay, so let's start off. We have square root of 7 plus 5. And it's going to be multiplied by the term square root of 10 plus 3. Over square root of 10 minus 3 over square root of 10 plus 3. Now let's use our foiling methods on top and bottom. So we'll take this square root of 7 and multiply it across everything inside this set of parentheses. And we'll take this 5 and multiply it across everything inside those parentheses. And on bottom, we'll do the same thing with the square root of 10. And then that negative 3 will get distributed across. So we actually write that out. We get square root of 7 times square root of 10 plus square root of 7 times 3 plus 5 times square root of 10 plus 5 times 3. It's pretty lengthy, but some stuff may cancel out, especially on the bottom. So let's work with the bottom. Square root of 10 times the square root of 10 plus the square root of 10 times 3. Okay, that's going to be minus 3 times square root of 10 minus 3 times 3. So now let's go through and simplify what we just developed. So square root of 7 times square root of 10, that's going to be square root of 70 plus 3 times the square root of 7 plus 5 square root of 10 plus 15. That's what the top is going to look like for now. And on the bottom, we have square root of 10 times square root of 10. That's going to be the square root of 100, or just 100. Note that these are going to cancel out. Notice that these middle terms will cancel out, and we have negative 3 times 3, which is 9. Negative 9. So to take the steps we just found, oh, excuse me. that should actually be 10 because the square root of 100 is 10 minus the 9 we had. And as you can see, what we're going to have, after we do this bottom division, we're going to be left with 1, or just the answer being equal to what we have on top. And that being the square root of 70 plus 3 times square root of 7 plus 5 square root of 10 plus 15.